Hey everybody, let's do a hands-on tutorial with DynamoDB right now. So first, log in to your AWS console, as I have done, and then type in DynamoDB. It's going to look like this, and let us click Create a Table. Okay, the first table I would like to create, first off I need some type of context for creating a table. Let's say that I'm going to create a database of donut varieties. And so I will call my table name donuts. And I will do an ID and make that a string. And that's really all I need. Now notice that, so because it's a string, I can use some type of real name. But I'm not going to do anything else. I'm just going to say create. It should take about 10 seconds for this to be created. All right, it's done. Maybe it was closer to 5 seconds. Okay, to start inserting items into this special kind of database, I'm going to click over on items, which is the same thing as records or rows if you're thinking about a relational database. And if I want to create an entry, I'm going to click on create item. Okay, so it's already put in there the primary key, and in this case, there's a variety of ways that I could do this, but I'm going to do it this way. I'm going to type in donut1 here, and then now I could just leave it at that, and that would be fine. And then I'm going to go over here to append a string, and I'm going to add another column called an attribute in this type of database. And I'm going to give a name to my donut, and I'm going to call it apple fritter. And I suppose if you want to split hairs, technically I could have made the ID apple fritter, but suffer me to do it this way for a second. So go ahead and hit save. All right, let's do another one. We'll call this one donut2, and we are going to add in an attribute, the equivalent of a column, and we'll have the name of this donut be jelly filled, and we will hit save. And let's see, let's do another one. We'll call it donut3, and this one will make it a cronut. So we'll give it another name and call this one cronut. Okay, so let me do something a little bit unique here, and I'm going to add in another column that the other ones do not have. And so this is where it becomes different from a typical relational database. We can just arbitrarily have more or less columns, and you have to leave it up to your software to deal with the presence or the absence of these columns. So let's see, I'm going to have a little column here that says notes and say this was a big seller at the fair. Let's just say I had a food truck or something. All right, so I'll hit save. All right, so because this is designated as a primary key, I should not be able to create another item or another row with the same primary key. So let's go ahead and test that out. So I will type in donut1, which I've already used, and I will do string, and this time, okay, again I'll go name, but this time I will do raspberry fritter, and then I will hit save. And it gives me an error right here. It says conditional request failed, status code 400, error code conditional check failed. So this wasn't entirely clear in terms of what the problem is, but I do happen to know that it's because I violated the primary key constraint there. So I'll just hit cancel. If I change it to primary 4 and hit enter, then everything would be okay. All right, let us go ahead and create another type of table now. And I'm going to have a little bit more information this time. All right, let's think of another business context. Let's just pretend that we have sensors all over town. What would we need sensors for? Let's, or maybe not sensors, could be sensors. Yeah, okay, I'll go with sensors. Let's just say that for our city, we've set up Raspberry Pis and maybe they're solar powered or something, and they are collecting temperature readings every 10 minutes or so. And every time it collects a temperature reading, it is going to send that temperature reading update to this DynamoDB table. All right, so I'm going to call this one sensor readings from my Raspberry Pis. And the primary key, again, I'm going to give it an ID, and I'll use this to distinguish the sensors. So if I have 10 different sensors in my town, maybe I could call it, and in my town was called Provo, I could call it Provo 1, 2, 3, 4. And maybe if I were to go across the US with this, I could have a different city name in each ID, and then just increment the number after the city name for the different sensors that I have. Okay, now here's where it's going to get unique. I'm going to add this thing called a sort key so that I can create a primary key, or sorry, a composite key. If you recall, last time I just did those donuts and I can't reuse the key name. So if I'm going to get multiple readings on a particular primary key, I need to have something else as part of the key that makes it unique. So I'm going to make a composite key with 2 columns. And I'm going to have this one called timestamp. And, well, there's actually 2 ways I could do it. Timestamp is a little bit harder to look up. You can Google it all the time. It'd be easier to write just like date. So I'll do it like that. And I'll make my date be a number. Okay, so that's all I need for now. I'm going to click create. Okay, while it's taking 5 seconds to create, I'm going to scroll down a little bit here and just note something right here. It says provisioned read capacity units. Every single interaction that you do with your table is measured in some. It's considered to be an API call. So if you do a read or a write to your database, it's considered to use up part of a read or write capacity that you allocate. And so this one is allocated with 5. And you can go up here to capacity and you could change this. So basically, with 5, it means I can get like 5 API calls or 5 reads per second, or I can have 5 writes per second. And it gets there are some nuances to this. Kind of under the default way of doing things, technically you actually get 10 reads per second, but I don't want to go into the dirty details right now. But just be aware that if you needed to have more capacity for your database, because it's you're getting a lot of traffic, then you could just up the amount of capacity that's provisioned, not necessarily used, but provisioned, and with that you're going to be paying more for just having that allocated. Okay, so it only took a couple seconds for it to be created. I'm going to go over here to items. It is now empty. So let's go ahead and create some entries. Right now we have our composite key composed of ID and date. So I'll have my first sensor called, I'll call it Provo 1. And then for the date, for when it's making this reading, I'll do 2020, and what is the date today? April, so 04, and then it's the 9th this week, 0409, and I could go into seconds or something like that after it if I wanted to. And then let's go ahead and say I'm taking a measure of the temperature. Then I'll just type in an additional field here, temperature, and I'll say that it is currently 55 degrees, and I will hit save. All right, let me create another entry now. Again, this time I'll use Provo 1 as my sensor ID, and the date, let's just say I decide that this is my reading for tomorrow if I were doing this once per day. And so then it would be the 10th, April 10th, 2020. And the temperature tomorrow is going to be 60. Okay, now I have 2 entries. Let's just go ahead and make another entry because I want to show off the searching and the search fields. So I'm going to call this one Provo2, and it did a reading on 2020-04-09, and then its temperature, make it, oops, actually I think I was going to, let's again make that a number, and we'll say that again this one's got 56. It's in a different part of town where it's a little bit warmer, and maybe just for giggles I'll do something unique, and I'll just put in a string here, and I'll call this, say this is notes, and I'll say taking this one offline, last reading from this particular sensor. Okay. All right, so I mean, it kind of looks like a regular database at this point, or a set of records in rows, but technically it's not, because you can have kind of arbitrarily columns filled out or not filled out. Okay, so there's two ways that we can search things. One is scan, and scan, if you have less than 1,000 items, scan is not so bad. It just simply returns every single item in your database in DynamoDB. But if you start getting into higher numbers of items that are in your database, then scan is a very costly thing to do, even if you're doing a specific narrow search. Query is actually a much nicer one to do. So with query, let's go ahead and say I want to look for only Provo1, and I'll just kind of leave it at that, say start search, and now I have only these entries. Okay, so that's not terribly exciting. You could also use the sort key here to do something like between. So imagine you had millions of entries. You could get your date between a particular range, and it'll return back some information. So as long as you're just working with these two parts of your composite key, you're going to get a very effective search. All right, obviously we don't usually work with items in this way. We usually interact with things via software. So if we were to do something like AWS DynamoDB SDK Python, enter that in. You look for, now this one based on its link, we're in the Amazon documentation. So if I click on that, here's DynamoDB. We want the SDKs section for that. And for any of the products in AWS, there's going to be an SDK section. So it doesn't matter, which language you want. You can just go to the one you prefer, and then you can see some code snippets for example, creating a table. And it's a little weird the first time you look at it. You import a library for DynamoDB specifically, and you connect to a particular URL where your DynamoDB instance is hosted in a particular region. And so here's where you're creating your primary key. In my case, this would be like sensor ID 1. And then right here, this right here would be like my, this is called the key type range. So this is my sort key. So in my case, that would have been the date field. And then down here, you can actually set like what type of attribute it is. So there's a couple ways, so it looks a little convoluted at first, but basically you're just determining your primary key and what type each of those things is, set your read and write capacity units, and then you're off to the races as it runs that particular function. And then reading and writing from a database, again, you would just go over to the documentation for whatever language you're looking at. And so this one says for creating an item, which is the same thing as a record. Isn't it nice that they've done some of the work for you ahead of time? Anyway, again, connect to DynamoDB, and then select the table that you're going to be working with, set some values that are potentially your primary key and your sort key if it's set up that way, and then you have this little object that gets, well, your item is always the thing that gets inserted into the database. So if this is your primary key, the year, and your sort key, the title, or vice versa, the additional attributes you would be adding are right here, and the put item command should be the thing that runs the command and makes it work. So if you can do the other part, which is set up your table and stuff like that, and you know how to program a little bit, you should be able to do this part as well and have a running application. So that is it for now. There's definitely a lot more to this, but I'm going to leave it at that. So it's been fun doing a lot of this AWS stuff this semester. I hope that you guys all do well in your future endeavors and can make great use of this material. Have a good one.